Good evening, fellow scholars. My name is Andy Sperl, and today I will be sharing with you a module of Excel report probabilities. And this is for an Excel report for math. What I'm going to be showing you here in the Excel report today, worked on and finished. And what this pretty much is telling you is a probability of a survey. Now, the probability here, you have no, yes, women, and then yes, not sure for men. And it's going to give you the fractions, the simplified fractions, the decimal to the nearest thousandths, and the percent to the nearest tenth. Now, the response from men and women total, you have yes to 195 men, 240 yes to women, and then you have the total of all together who said yes is 435. Now down here you have a response of no. 285 men said no. 215 women said no, which gives you a total of 500. Now we're going down to the ones that say not sure. Men are 20, women are 45, and all total together 65. Now if you add the totals together, the total of men together is 500, plus the women is 500. And if you add those two together, you get 1,000. Now, what this is implying is this is an empirical problem because it is an experiment. It's an experiment that the data was collected using an unbiased survey and the population sample was taken randomly. And this data can be used to be projected onto a much more larger population. In this sample of 1,000 people, I might decide what the city or country or state might think the results are endless, which means you can go on and on. There ain't no end to it. You can keep going on with it. And now we go on to problem number 2. The probability of products and sums of rolling two dice. Down here we have our chart, which shows us our different events. And then we have our fractions, our simplified fractions, our decimals to the nearest thousandths, and then our percent to the nearest tenths. Now, what I got from this is if you were to roll 2 dice, the probability of getting the sum of an even is 18 out of 36, which reduces by 1/2. If you were to roll the same dice, 2 dice, the probability of getting the sum of a multiple of 3 would be 12 out of 36, reduced to 1/3. Now, if you were to roll 2 dice, the probability of getting a product of a prime is 6 of 36. If reduced, it goes to 1/6. Now, if you rolled the 2 dice, the probability of getting a product of 12 would be 4 of 36, which we could reduce down to 1/9. Problem number 3. We are looking at a total number, total winning amounts, which is here. And then you have your outcome, your probability of fractions, your probability of decimals, your percentages, your expected outcome, and then over here you have your buyer's expected outcome, which is a loss of $1.93. Your seller's expected outcome, which is a gain of $1.93. And the seller's expected outcome for selling 5 million tickets. Yeah, these are lottery tickets, people. Which is 9,007,000. Now, in this problem, we graphed and calculated the probability of a scratch-off lottery ticket. We did this in numerous ways, such as calculating the data into fractions and decimal percentages and dollar outcomes. Our data range was from 0 to 100,000. We also calculated the expected outcome if 5 million of the said lottery tickets, which concluded in 9,750,000. Now, what I also did was there was an extra exercise, which I did Google. I looked it up on Google. And I was looking up on how much lottery tickets are sold every month. Now, Gary Chief, who is the chair man of the Powerball game for the Multi-State Lottery Association told ABC News that 371, yes, 371 million tickets were sold within 1 week. And that's just for 1 week drawing. Now, could you imagine if you were to add that up and go into the months and the years? If you're going to the years, you probably get up in the billions. So that right there shows you just how much money the Lottery Association makes on just a weekly basis. That's a lot of money. Okay, then we have probability. We have question number 4, which gives us our probabilities, which are shown here. We have our probabilities there. We have our fractions, our simplified fractions, our decimals to the nearest thousandths, our percentage to the nearest tenths, and down here we have some charts, and an odd diagram over here to the right side, which shows our events, our odds in our favor, and the odds against. Now over here we have our odds in the favor and odds against in the pie graph, which shows our odds in our favor, which are here, and our odds that are against. Now if you were to calculate and add all these together, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 in our favor, 9 over 4 in our favor. Now if we were to go against the odds, our odds against us are 4 out of 9. Now, what I did get in this problem is we went through the fundamentals of graphing probability values for an event, as well as the individual values for the odds in favor of and against a certain outcome. Now, after completing the data table, we also instilled 2 more additional forms of outcome visualization, using a 3D bar graph and 2 colored circle dots, graphs for a maximum of thorough visualization of this problem. And now on to number 5. Number 5 is talking about our U.S. military. It talks about the branches: Army, Navy, Air Force, and Coast Guard. Total of men, women, percentage of men and women in our United States Armed Forces. Population of the service branches of the Coast Guard, Air Force, Marines, Navy, and Army, which is shown on the graph to the right. Now down below, it is showing us a simple little graph design here, which we are taking women from the Air Force, Marines, and Coast Guard, but we're doing that in fractions, simplified fractions, decimals to the nearest thousandths, and percents to the nearest tenths. And that goes for men in the Army, women not in the Marines, and men in the Air Force. Now, in this problem, we calculated the gender population in each of the 5 branches of the armed services. We also categorized this data in terms of fractions, simplified fractions, and decimals to the nearest tenths. After successfully logging all of the armed service branches, the data we created a bar graph, which is there on the very top, shown right here, represents all of the populative value for all of the armed branches in one setting. Now, what we do have here for number 6 is a binomial experiment, is an experiment which satisfies these 4 conditions. Now, the 4 conditions are as follows. Fixed number of trials. Each trial is independent of the others. There are only 2 outcomes. And the probability of each outcome remains constant from trial to trial. And down here, we do have a binomial distribution formula, which does show the following. We do have a binomial distribution formula with variable identifications to it, which shows all that there. B equals binomial probability. The X equals the total number of success. The P is a probability of a success on an individual trial. And Q equals 1 subtracted from P is a probability of getting a failure on any one trial. and the n equals the number of trials. Now, in this problem, we analyze the principle behind the binomial experiments we use, 2 binomial formulas, to discover the amount of outcomes an individual could have for any given event. This would be invaluable to the individual for carefully planning from that point. We also categorize the probabilities by decimals and percentages to offer increased understanding, which down here shows a formula for that, right there. And that is the end of my Excel report for everyone. I hope you have a wonderful day and a wonderful night. And I wanted to thank Ms. Benzie for allowing me to do this report and turn it in. May you all have a wonderful night, and good luck to all of you scholars out there.